I hope you all are doing well. So today we will be starting with the chapter Trigonometry. Now this chapter is a chapter which does not contain a lot of concepts, does not have a lot of logic. The only thing that this chapter is filled with is formulas. Formulas, ratios, identities. There are only these things in this chapter. So if you need to study this thing, you need to have good memory, because there are going to be a lot of formulas that we are going to study in this chapter, and you will be asked to remember all those formulas, because if you remember those formulas, only then you would be able to solve the questions of this chapter. So definitely considered to be a tough topic, only because there are a lot of formulas and identities in this chapter. Apart from that, if you, let's say, remember all the formulas, then solving questions is very easy. We will be looking at all previous year questions in this chapter, and you will see that all those questions are pretty easy. The only thing is that you must know the formula, which one to use where, and you must know the exact formula that is going to be applied in that question. So again, a chapter not very large. It is going to be a very short chapter. The only thing is that we are going to be looking at a lot of formulas in this chapter. First, again, just a brief introduction of angles and trigonometric ratios. Again, all these things you have already done from your class 10th. The only new thing that we will be studying in this chapter would be trigonometric series, and we will be looking at a few properties of triangle, and then general solutions. So this is the most important topic in this chapter, general solution. Generally questions are asked from this topic only mainly. Apart from that, all these other topics are completely filled with just formulas and a few other concepts that you've already covered in your class 10. So there isn't anything new that you will be looking in this chapter. So let's start. Talking about angles. Whenever we talk about angles, the first thing that should come to our mind is a circle. Now, measuring an angle of any circle or any arc is done by two ways. One is the sexagesimal measurement system, and the second is the circular measurement. In the sexagesimal measurement system, we generally use the degree format. I hope you all know what exactly degrees are. 360 degrees. A complete circle is a 360 degree, half circle is a 180 degree. And circular measurement is where we use radians. So this is generally represented by a pi. So let's say if I am talking about a complete circle, so 360 degree becomes equals to 2 pi. So that is how circular measurement is done. Now, if I was to get into the details of sexagesimal system, let's say if this is a circle and I divide this circle into 360 equal parts. If this circle is divided into 360 parts, then 1 by 360th part, this would be called as 1 degree. It is generally represented by a small dot in the superscript. And when we talk about 1 by 60th portion of a degree, 1 by 60th portion of a degree, it is called 1 minute. And this is how it is represented. And let's say if I talk about 1 by 60th portion of a minute, then it becomes 1 second, and it is represented by inverted commas, double inverted commas. So this is how degrees, minutes and seconds generally work. Now talking about circular system, what happens in circular system is, let's say if I have a circle and I consider, let's say, an arc from A to B. So this arc length from A to B would help me determine this theta, the angle that this arc length AB is composing at the center. So how would I write down my theta for this one? My theta would be equal to arc length AB divided by R, where R is my radius of the circle. So generally this theta comes out to be in radians, which is somewhere or not there is going to be a pi included. So let's say if I talk about a complete circle. So if I talk about a complete circle, I hope you all know what the circumference of a complete circle is. Circumference. So the circumference of a circle is 2 pi r. Now let's say if I want to find out the angle that is bounded by the complete circle. So I would say theta would be equal to arc length. My arc length would be 2 pi r completely, and divided by the radius. So from here r and r would be cancelled out, and 2 pi. So my complete circle becomes 2 pi. Now if my complete circle is 2 pi, that means I can find out each and every angle and each and every degree, right? So the method of conversion is basically this way. If 360 is 2 pi, that means pi would be 180 degree. And if pi is 180 degree, for me to convert radian into degrees, what can I simply do? Multiply by 180 by pi. And if I need to convert degree into radians, I'll multiply by pi by 180. So one important thing that you need to remember is that in radians, almost every time you're going to find angles related to pi, and in degrees, there is not going to be any pi, because since I'm multiplying it by 180 by pi, my pi would cancel out the pi which is in radians, and I would get a numerical value in degrees. Now there are a few standard radian and degree conversions which you should remember. Again, you have already done all these things. So let's say if I have pi by 2, so it is 90 degree, pi by 6, this is my 30 degrees. Let's say if I have pi by 3, this is going to be 60 degrees. Of course, now you can simply multiply them by 180 by pi, you'll get the degree that we are talking about. And then we talk about pi by 4, which becomes our 45 degrees. So these are just some standard degree and radian conversions which are mostly used in our questions. So you must remember these. Now let's come to trigonometric ratios. Of course, these are things which you've already studied in your 10th. Let's say if I have a right angle triangle. This is my right angle triangle, and of course it is following the Pythagoras theorem, where this is my hypotenuse, I have a perpendicular, I have a base, and I know that my h square is equals to p square by plus b square. And let's say if I consider any angle theta. Now the angle that I'm considering theta here, the side of triangle just below it would become my base. Now this is my base and this is my perpendicular. The side which is opposite to my theta would be my perpendicular. So remember this thing. Side which is opposite to theta always becomes my perpendicular. Now let's say, had I assumed my theta to be here, then this would have become my perpendicular and this would have been my base. So keep this thing in mind. Now again, finding out your sine. Sine is a trigonometric function. Now finding out your sine of this theta would be simply perpendicular by hypotenuse. Cos is base by hypotenuse. Tan is perpendicular by base. Now again, it is recommended for you to remember all these things. If let's say you do not remember, there is a trick for you to remember all these things. There is a sentence. If you remember that sentence, based on the first characters or first letters of that sentence, you can write down your trigonometric ratios. So that sentence is, some people have curly brown hair turned permanently black. So if you look at this sentence, some people have. So you can see for sine, we have some people have curly brown hair turned permanently black. So if you remember this sentence, of course, it becomes easy for you to remember the trigonometric ratios. Apart from that, if let's say you have some better way to remember, some better sentence or some other tricks, then of course you can go with it. Apart from that, this is the way to remember sine, cos, tan, and cosec, sec, and cot. These are going to be completely the reciprocal of your sine, cos, and tan. So cosec and sine, these are reciprocal of each other. Cos and sec, these are reciprocal of each other, and tan and cot, these are reciprocal of each other. So this is one thing that you must remember. Now there is one more thing, I'll just write it down here, that you must remember. Let's say I have my trigonometric function. Let's say this is my function. And here I have my co-ratio. So for each function, there is a co-ratio. So for example, for sine, the co-ratio is cos. For cos, the co-ratio is sine. So it goes vice versa as well. For tan, the co-ratio is cot. For cot, the co-ratio is tan. Now you can see that tan and cot are co-ratios of each other, as well as they are reciprocal of each other as well. However, for sine and cos, this is not the case. For sec and cosec also, sec, the co-ratio is cosec, and for cosec, the co-ratio is sec. So remember this thing. Now again, co-ratio does not mean they are reciprocal of each other. This is just a way of representing or a way of attaching these two functions together. So this is what we call as co-ratios. Now talking about a few trigonometric identities which you've already studied. Sine square theta plus cos square theta is equal to 1. Sec square theta minus tan square theta becomes 1 as well. And cosec square theta minus cot square theta becomes 1 as well. Now if you were to ask me the proof of all of these, I'll just show you the proof of one of the functions. Let's say I have sine square theta plus cos square theta is equals to 1. Now, what was the trigonometric ratio for sine that we studied? P by h, right? So this would become p square by h square. Plus for cos it used to be b by h. So it would become b square by h square. Now here you can see that my LCM would be h square only, and here I would have p square plus b square. Now by Pythagoras theorem, we had seen this formula that h square is equals to p square plus b square. So this can be written as h square by h square. So this gets cancelled out and we have left with 1. So this is generally how you can prove your other identities as well. However, this is something you've studied already, so not a very new thing. Of course, you must be remembering these formulas as well. Now here are a few standard values of certain angles for sine, cos, tan, cot, sec and cosec that you must remember. You've already seen this table earlier. So for sine 0 we have 0, for 30 we have 1 by 2, 45 we have 1 by root 2, 60 is root 3 by 2, 90 is 1. Coses, simply it is going to be the reverse values of sine. So whatever value we had for sine A at 90, that same value we will have for cos at 0 degrees. So for 90 we had 0, here we are going to have 1 here, root 3 by 2 is here, so root 3 by 2 becomes here. So keep this thing in mind. So 90 minus theta is basically, sine of 90 minus theta is cos theta. So we can represent this as sine of 90 minus theta as cos theta. Similarly for tan and cot also the same thing works. For tan, 90 minus theta would become my cot theta, and my sec 90 minus theta would become my cosec theta. So this is the general way of finding out your angles. Apart from that, let's say if you only remember sine and cos, it is fine for you. You can find out your tan. Tan would simply be sine by cos. These are again formulas that you've already studied. So sine tan theta is basically sine theta by cos theta, and my cot theta is 1 by tan theta, sec theta is 1 by cos theta, and cosec theta is 1 by sine theta. Again, very basic stuff you've done in your 9th probably. So these are certain values that you must remember. Now the places you might be seeing in the table that the values are not defined. What does this mean? Now the value is not defined. That means while doing my sine by cos, that means in my denominator I am getting a value which is equals to 0. If in my denominator I have a 0, of course I do not know what that value is going to be, right? It is going to be undefined. So that is why we write it as not defined, or can be represented by infinity as well. So these not defined values can be represented by infinity as well. So keep this thing in mind. Apart from this, let's say if I look at the quadrant structure. So let's say if I have my axis, let's say this is my xy plane. Now here I'm going to represent not by the numbers or values in my x and y axis, but by the angle. So what would I call this angle to be? This complete angle. This is going to be pi by 2. And as I keep increasing or as I keep going towards y, keeping my, let's say, origin constant, my angle is going to increase, right? So it is going to increase this way as well. So initially it was just the acute angle, then it is going to be increasing in the obtuse angle side as well. Then it is going to be more than 180 degree and then more than 270 degree. So just remember a few things. Angle up till here, this is pi by 2. Angle up till here, this is 180 degree or simply pi. This complete angle, this becomes my 270 degree. And if I was to represent my 270 degree, how can I do it? My 270 degree, I'll simply multiply it by pi by 180. So this would become 3 6 are 18, 3 9s are 3 2s are 3 3s are. So this becomes 3 pi by 2. And this complete rotation would become my 2 pi. Right, so I hope you must have understood this thing. Now, whenever we talk about trigonometric functions, sine, cos, tan, now all these values can be positive or negative depending on the quadrant they are in. Now this is my first quadrant, this is my second quadrant, this is my third quadrant, this is my fourth quadrant. Now there are a few things that you must remember. By using the cast rule, generally what we call this as the cast rule. So C starts from here, A, S, T. So this is my cast rule, and based on this cast rule I am able to determine whether my sine, cos, tan is going to be positive or negative in that specific quadrant. So if you look at the first quadrant, A means all trigonometric identities would be positive here. So if sine, cos, tan are positive, that means my cot, cosec and sec would also be positive. C, A, S. So here I have S. Now remember this thing, C starts from the fourth quadrant. So do not keep your C in the first quadrant. Keep this thing in mind. Now in my second quadrant I have S here. S means sine is going to be positive. So if sine is positive, that means my cosec would also be positive. And my cos and tan are basically negative. If my cos is negative, of course my tan would be negative, my cot would be negative, my sec would be negative. So only sine and its reciprocal is positive in this quadrant. When we talk about the third quadrant, here we have T here, which means tan is going to be positive. If tan is positive, that means sine and cos both are negative. because if any one of them is positive, my tan would become negative. So only tan is positive here and my cot is positive here. Apart from that, my cosec and sec both are negative in this quadrant. C means again cos, so cos is going to be positive, rest all values are going to be negative. And here my sec would also be positive. So this is the basic general way of representing any quadrant or signs, or determining the sign of any trigonometric function. So let's say if I have to find out the value of sine, let's say 2 pi by 3. So what is it going to be? How can I write it down? I can write it down as sine of pi minus pi by 3, where my pi is 180 degree. Now we know that sine of 90 minus theta. Now I hope you all know this thing. Sine of 90 minus theta, this is basically cos theta. And sine of 180 minus theta, this is sine theta only. And this works for each and everything. For cos also, it is going to be the same. Cos of 90 minus theta would be sine theta. Cos of 180 minus theta would be cos theta only. So whenever I have 180 minus theta, it's going to remain the same function. However, whenever I have 90 minus that same function, it is going to change to its co-ratio. So remember this formula. So I can represent this by pi minus pi by 3. So this would simply become sine of pi by 3. Now I know that 2 pi by 3. 2 pi by 3 would basically lie in my second quadrant. So in my second quadrant, my sine is positive. So that means here I would have a plus sign only. Now I can simply write down the value of sine pi by 3. What is my sine pi by 3? 60 degrees, which is root 3 by 2. So this becomes plus root 3 by 2. Now let's say if I was to find out the value of cos 2 pi by 3. Cos 2 pi by 3, again I would write it down in the same way, pi minus pi by 3. Now of course I do not directly know the value of cos 2 pi by 3, right? So I have to convert it into any one of these angles that I have here. So that is why I use this formula, pi minus pi by 3. And this would become now cos of pi by 3. However, we know that 2 pi by 3 lies in the second quadrant. So in my second quadrant, my cos is always negative. So I would have a negative sign here. And this would become minus 1 by 2. Because cos of 60 degrees is 1 by 2 and pi by 3 is 60 degrees. So this is how you generally find out your angles. Of course, basic stuff you've already studied. Nothing new. Still, the introduction is going on. There hasn't been any new formulas you've studied. Just a revision of all the things that we've done. Now, of course, here since you know that sine theta is sine 0 is 0, that means sine pi would also be 0. I know that my sine of pi would also be 0. Now at any time, if I take a 180 degree turn, my sine is going to be 0 only. That means I can say, what would this imply? That my sine of n pi would always be 0. Of course, sine, whenever my n is 0, my sine is also 0. So here I would say that my n belongs to integers. Be it any integer, my sine of n pi would always be 0. However, for cos, this is not the case. Whenever I have cos pi is basically minus 1. So if cos pi is minus 1, that means cos of n pi, how can I write it down? When I have cos 0, it is going to be 1. When I have cos 2 pi, it is going to be 1. That means whenever my n is even, I would have this value as 1. Whenever my n is odd, I would have this value as minus 1. Here again, n belongs to integers. So keep this thing in mind as well. Apart from that, when we talk about pi by 2, sine of pi by 2 would be 1, sine of minus pi by 2, or let's say sine of 3 pi by 2, this would become minus 1. So whenever I have n pi by 2, where my n is odd, if my n is odd, I would have sine as minus 1. Sorry, whenever I have sine of n value, let's say if I was to talk about sine of n pi by 2. So here, how can I represent this? Of course, you know that pi by 2, here n is 1. When I have sine of 3 pi by 2, here my n is 3. When I have sine of n pi by 4, which means now my n is 5 pi by 2. For 5 pi by 2, I would have 1 again. So whenever I'm taking a circle, I'm having my value repeated again. So here, how can I represent this for sine? For sine, if let's say n is equals to 1, 5, 9, 13. So when n is in my multiples of 4, I would have this value as 1. And when my n is in the multiples of 3, then again after 4 spaces, we have let's say 7, then I would have 11, and this would go on, then I would have minus 1 as my answer. So keep this thing in mind. For sine n pi by 2, for n value starting from 1 with 4 common difference, I would have 1, 5, 9, 13. For all these values, I would have my sign as +1. And for values where my first number starts from 3 and then again has a common difference of 4, 3, 7, 11, there I would have these values -1. So keep these things in mind. Again, very basic stuff. Now talking about a few negative value of our trigonometric functions. Let's say if I have sine of minus theta, it would convert into minus sine theta. If I have cos of minus theta, it would remain as cos theta. Now when I talk about tan of minus theta, it would become minus of tan theta, because if I write tan as sine theta by cos theta, my cos theta would remain positive only. However, my sine theta would become negative. That means my entire function would become negative. So tan theta also becomes negative. Similarly, cot theta also becomes negative. Cosec theta also becomes negative. Sec theta, since it is the reversal of cos theta, so it would remain positive as well. Now let's say if I was to show you the proof of why this is happening. Let's say this is the angle that I'm measuring. This used to be my theta. And this is my triangle. This is my perpendicular, my base, and my hypotenuse. So for here, of course, my sine theta would be written as perpendicular by hypotenuse. Now let's say if my angle is in this way. That means here. Till now I was measuring my angle this way. Now remember one thing. Angles are always measured in anti-clockwise direction. So angles are measured in anti-clockwise direction. Then they are going to be positive. If the angles are measured in clockwise direction, then they become negative. So if I talk about minus theta, that means I have to go clockwise direction. This would become my minus theta. And here again, if I look at this theta now here I would have perpendicular. Now this value here, this perpendicular, of course this value is going to be minus p here. So that means this distance is p. The absolute value would be p. However, now my value that I'm going to put, my y value would become minus p, right? Because y value would be negative here. So simply my sine of minus theta would become equal to minus p by hypotenuse. My hypotenuse would remain the same. My hypotenuse is basically the distance that I'm measuring. So you can see that sine of minus theta is basically minus of sine theta. So that is how the proof of sine theta happens. Similarly for cos, you can write it down. Cos would be base by hypotenuse. So it does not get affected because base also remains positive. Hypotenuse also remains positive. So this is the proof of how negative values of trigonometric functions are found out. Rest, you all can prove it by yourselves. Apart from that, it is recommended that you remember all these things so that it is easier for you to solve questions.